Hello and welcome to yet another video of Cornerstones of Math. In this video, we are going to factorize x plus y times y plus z times z plus x xyz, and I gotta say it is not as easy as it looks. But this problem can still be solved in two methods, and I think that both methods are beautiful and they might be useful when you encounter similar situations. So let's get started. The first method is what I would like to call rearrange in descending order, which is something like this. You see, this is type of the problems where there are no easily identifiable common factors and no directly applicable formulas. But when you hit this kind of roadblocks, perhaps the following methods might help. First, find a variable having the least degree. Then rearrange the given polynomial in descending order of that least degree variable. Then you may be able to spot the common factor. Let's see how this method actually works in our problem. Here, x, y, and z are all of degree 2, so we can pick whatever variable we place among x, y, and z. Therefore, let's pick x. That is, we expand this polynomial and rearrange in descending order of x. So if we expand this part, we have xy plus zx plus y squared plus yz. So if we expand this part, we have xyz plus x squared y plus z squared x plus zx squared plus y squared z plus xy squared plus yz squared plus xyz, then plus xyz. Therefore, for x squared terms, we have x squared y plus zx squared, and for x terms, we have xy squared plus z squared x, then xyz plus xyz plus xyz, so 3xyz. Then we have remaining terms y squared z plus yz squared. Therefore, we have y plus z x squared, then y squared plus 3yz plus z squared x. And as for this part, let us write yz times y plus z. So we have the descending order of x, but where do we go from here? Well, we still cannot find the common factor, but we can find out something else. This might take some experience and intuition to find out. You can think of this as a trinomial of x, which can be factored into ax plus b times cx plus d, right? If you consider x as the only variable and considering y and z terms as coefficients. You see, the method of applying this formula can be easily done like this. Basically, we have to guess these coefficients a, b, c, and d so that they give ac, the coefficient of x squared term, and bd, the constant term, and then if we multiply like this to obtain bc and ad and add them up, they give ad plus bc, the coefficient of x term. Using this trick, you can easily factorize the polynomials like 6x squared plus 5x minus 4 by guessing these coefficients 3, 4, 2, and negative 1. In our case, the coefficient of x squared is y plus z, the constant term is yz y plus z, and the coefficient of x is y squared plus 3yz plus z squared. And this is actually the case where guessing is pretty easy. Let's write y plus z here and 1 here. And as for the next part, let us split yz y plus z into yz here and y plus z here. Then 1 times yz gives yz, and y plus z times y plus z gives y squared plus 2yz plus z squared. So if we add these two, we obtain y squared plus 3yz plus z squared. Therefore, this polynomial can be factored into y plus zx plus yz and x plus y plus z. So we have xy plus yz plus zx times x plus y plus z. You see, this problem is harder than usual because, as you can see, there are no two-term factors. Nevertheless, the result is beautiful. The second method comes from the fact that we have sort of cyclic expression right here with x plus y plus z, and z plus x. Therefore, by intuition based on lots of experience again, let us substitute x plus y plus z with a. Then x plus y equals a minus z, and y plus z equals a minus x, and z plus x equals a minus y. As for this part, we have an expansion formula for that. You remember these formulas, right? These formulas can be useful when dealing with relation between roots and coefficients of cubic equations. So by the formula, we have a cubed minus x plus y plus z a squared plus xy plus yz plus zx a minus xyz for this part, and we have plus xyz here. So minus xyz and plus xyz cancel out. Also, remember that we have substituted this x plus y plus z part as a. So we have a cubed minus a times a squared plus xy plus yz plus zxa. And here this a cubed term and this a cubed term cancel out. So we have just xy plus yz plus zx times a, which is xy plus yz plus zx times x plus y plus z. And I gotta say, this method is beautiful too. And that's all for today's video. Now, if you want to watch other videos that utilize the first and second methods I just explained, then please go check out these two videos. Also, please don't forget to hit the like and subscribe buttons if you enjoyed my videos. Thank you all for watching, and I will see you in another video.